Hey, yo, what's up? We're doing another one of these homework walkthroughs, run-throughs, covering things. So again, I do this pretty fast. I don't give you all of the answers, but I kind of help you through the homework assignment. So here is the 7-2.2 homework assignment. It was 9 through 35 odd on page 429. So again, take time, pause these videos. I don't take a lot of time here. I'm going to burn right through these super duper crazy fast. I already crossed out the evens, and by mistake I crossed out this one. Oh, look, it's already done. So number 11 right here. I'm skipping number 9. Number 11, as you can see, that's a 2 to the 0, so it don't count. So you just add the 2 and the 7 and you get 9. Number 9, u plus u plus u, so it's going to be -6 to whatever all of those small little exponents add up to. Remember, when you see the big kids multiplying, that means the little kids are doing addition. Okay, here we go. Oh, I like this one. Here we go. So we have a 5 and a -5. That would make the whole thing to a 0. I'm pretty sure you can figure out what that would simplify to. Moving forward, 15. There's only one big kid. Technically, there's a 1 here. 5 times 1 is 5, and then C and 4 would add to a number. You add the little kids. Big kids multiply, little kids add. Number 17, there are no big kids. There's only X values and Y values, so I'm going to cheat, kind of give myself a place to land. Let's see here. We have a 5 and a -6. That'd be a -1. We have a 2, and there's nothing there. Oh, yeah, there is. There's a 1. That'd be a 3. Now, what does it say? Rewrite expression using each base only once. Okay, so it doesn't say anything about removing the negative exponents, but if it ever said write it without negatives, that y to the 3 would stay, and that x to the 1 would move to the bottom. So again, make sure you read the directions carefully. If it says negative exponents are okay, you can leave it like that. If not, you want to move them. Remember, negative exponents move to the other side of the fraction bar. Ew, look at number 19. I'm going to set a big old blank fraction bar just in case, because I never know what's going to be left over. Let's see here. I'm going to go for the big kids first. We have a 4 times a 5, so we have a 20. Why does it go above the fraction bar? Because it's a positive times a positive, so it stays above the fraction bar, and it's just, well, it's positive in general. We have M's and R's. Okay, so before I land, let's see, we have M's and we have R's. Uh-oh, there was a -1 hiding there the whole time. So this is a -20. Ooh, good save. Gotta take my own advice and go slow sometimes. So we have an M to the 2, M to the 1, so we'd have an M to the 3. We have an R to the 3 and an R to the -4. So we'd have an R to the -1. So we'd have a -20, M to the 3. Why does that go above? Because the 3 is positive. Now this R is going to go down here. Okay, that was a nice one. I did that one because that one would just look nasty. Don't forget, there's negatives hiding in plain sight, and then there's ones hiding in plain sight. So stay on your guard. So it's 423. Let's go to 430. Page 430. We got 9 through 35 odd, so we're almost getting up in there. Ooh, here we go, number 21. I'm going to help you out with this one. Scientific notation. Now, there is a nice little mini lesson on scientific notation inside the 7-2 notes. I would recommend looking at it. You don't need to write down the notes, but if you understand scientific notation, get after it. Try some of the IXLs. Otherwise, this problem could probably hurt your feelings a lot. The distance light travels in 1 second is about this many. Saturn is almost this many light seconds from the sun. About how many miles is the sun from the sun is Saturn? Well, I got to slow down to read. Okay, so we got to take this number. That's just 1 light second. That's how far light travels in 1 second. That's pretty far. Then we got to multiply times this. Okay, so when you take a scientific notation times a scientific notation, watch what you do here. I'm going to go 1.86 times 10 to the 5 bracket. Now I'm going to write this one in scientific notation. 4.75 times 10 to the 2. Okay, how did I do that? Decimal goes here. It goes after the first whole number. That's not 0. 1, 2, 1, 2. Okay, 4.75 times 10 to the second power. Okay, so now I'm going to multiply. Basically, what you do is you multiply the numbers, and then you add the exponents of the 10. So I already know it's going to be a times 10 to the 7. The trick is when you multiply these numbers, do those numbers follow the scientific notation rules, or do they break the rules? Let's take a look here. 1.86, yep, times 4.75. Okay, all right, sweet. It's still scientific notation worthy. If this decimal was over here or over here, we'd have to take or give to that exponent. I go over all that stuff in the notes, but for right now it's okay. So it looks like it's going to be 8.835 times 10 to the 7th power. Ew, gross. Okay, here we go. Oh, yeah. Remember I talked about these in the notes. These ones, just use your calculator. What number times itself 4 times makes 625? Well, only really math teachers know that. It's 5 times 5 times 5 times 5. You want one of those. Okay, that's 5. Okay. Or you can just use your calculator. 625 to the 1/4. Oh no, a decimal. Yeah, I don't care. It works. Okay. Let's see here. What else we got? Ooh, to the 3/4. What number times itself 4 times makes 16? 2 does. 2 times 2 times 2 times 2 makes 16, and I want 3 of them. 3 times 3 times 3 is 8. Okay, let's double check. Again, I'm not expecting you to be super duper crazy masters of this stuff, but if you follow my thought process enough, then you can probably figure out what I'm doing there. Okay. Oh, gross. Look at you, number 27. What number times itself 3 times makes a 64? I think is that 4 times 4 times 4? I think it is. Let's check. 4 to the 3rd power. Hey, look, that is. Okay. So you need 7 4s. Oh, gross. So once you take away the 3, it becomes a 4. Then 7, 4 to the 7th power. Oh, that's disgusting. Oh, that's a big number. Hey, let's try the calculator the first time. How about 64 to the power of 7/3? Yeah, look at that. Same number. Weird, right? Crazy. Crazy how that works out. That big old number, I'm not going to write it down. Oh, 29. You are gross. I'm going to start you off. Take the 7 times the 2 times the 2 times the 7. That's basically going to be 49 times 4. So your number is going to be 196. And you're going to have a D value and a G value. The D value would come from adding this number and this number. The G value will come from adding this number and this number. Take your time. Do 29 super slow. Are you kidding me? This is a joke. Big kids multiply, little kids add. Gee, I wonder what number plus 2 makes 11. Probably not 11. I'll let you figure that one out. So you're trying to figure out what's missing here. So this number plus this number equals 1. What number plus a half equals 1? Come on, you kidding me? 2/3 plus blank equals 5/6. Ooh, I like that one. This will help. Change that to 4/6. 4/6 plus blank 6 will equal 5/6. I almost gave it away. Hey, that's it. All right, we're all done. 9 through 35 odd. Hopefully my help has helped you. Otherwise, it wouldn't be very much of a help at all. Okay, see you in class.